Alrighty, I think we're ready to get going. So we got Hangman project, finish up classes, talk about the next project. So just a couple things today. Should be good to go. So I forgot to bring my other computer, but I can get chat here on my phone. Let me do that so I don't forget. Maybe I can. I'll work on it. All right, so let me open up. We had that shell of project 2 for Hangman. We can take a look and see if we can just complete that here. I think that might be easiest. All right, there we go. Awesome. So again, you didn't have to use the methods. Nothing wrong with that. If you wanted to go without methods, if you wanted to use methods, great. I think that could work relatively well for the flow we were looking for here. But let's see. So we had whether or not we want to play again, right? Pick a word to guess. Ask them to guess the word. Ask for a number within range. This is a prompt we had already done, right? So we'll just fill this in, right? That method. So enter a number, or how many guesses do they get? How many guesses they get? 1 to 26, right? Sure. I'll bump that down a little bit. And then as long as we're still playing, display the word with blanks, given the word to guess, the letters guessed. Display all the previous guessed letters. Ask the user to guess a letter, add that to our letters guessed, and then keep on going. Right? And then ask if they want to play again. Sure, so we can just go top down, or and so to ask users if they want to play again, we'll ask, do you want to play again? Play again, and like that's yes or no, right? Y/N. Great. If they give me something, a Y, we'll keep on going. If not, they don't. Display the word to guess with blanks. Now this one was a little trickier, right? So given a word to guess and the letters, we have to do 2 loops here, right? Unless you found some other methods like contains, but 2 loops is what I had in mind without having to find anything else. So we said you can do for a char letter in the word to guess toChar array. So they would get 1 letter, 1 character out at a time. Come on, there we go. That one there, toChar array. So for every letter in the word that we're guessing, we're going to do something. So starting with the first letter, now we can do another loop, and we can loop through and see if we found the letter in the letters that we've guessed. So we need some way to track whether or not I found it. So I can say, hey, I want a Boolean for has guessed letter. And I'm going to assume it's false until I know otherwise. And then I can loop through again. I can say for char, I don't know what, a guessed letter or something? Guessed letter in the letters guessed toChar array. So we'll loop through all the characters in the letters that you've already guessed. So I'm going to start with my first letter. So if I put in the word to guess was Eric, and I'm going to loop through all the other letters. Maybe they've guessed A, B, C, D. Starting with the E, I'm going to look, is it an A, is it a B, is it a C, is it a D? No, if it's not, then my Boolean stays false here. But if they do match, I can say, hey, if the letter is equal to the guessed letter, guessed letter, there we go, nope. Gust letter, I can't spell, guessed letter. There's the guessed letter, there we go. And remember, these are characters, we can compare them directly. Strings, we can't. With strings, you gotta use the dot equals. But if they're characters, sure, one character can equal another character. No problem there. So if those match, then has guessed letter is going to be true. I did find it. When we're done looking at every letter I've guessed here, and again, you could do some sort of break or something if you wanted to be fancy, but I don't like breaks, so I won't. And it's not going to take that many more cycles to compare some more letters. It'd probably be a little bit more efficient if you broke the loop, but I don't care too much. After we've looked at every letter that has been guessed, we know, yes, we've found the letter or not, true or false. So if it's true, right, so if my has guessed letter, and now this is already a Boolean, right, so it already equals true or false. So what a lot of people do, they'll say, hey, does this Boolean thing equal true? Right? That's that's redundant because it already is true, right? If true equals true, well, you could just say if that Boolean value, right? If it's true, then I want to print out the letter. So I can print the letter, and I probably want to add like a space there, right? And if it's not the letter, then I'm going to print out an underscore and a space. So loop through it. For every letter in the word we're guessing, I'm either going to print the letter or the underscore, based on whether or not I find it looping through the letters I've guessed. And again, there's a contains method, which is really cool. You can ask, hey, if it's in it, but this is relatively straightforward too. It's not too bad here. So this will display the word to guess with blanks. Okay, so we should be able to do that. So we're going to ask, oh, we got to ask for the word to guess here, right? Let's see, ask for the word to guess. We'll print enter a word to guess for hangman. And then we don't have a scanner object yet. We could make a static scanner object if we wanted. Public static scanner, we'll call it keyboard. Put a new scanner given system in. This way I don't have to create that scanner every time. Sure, that's an option. Scanner, there we go. So I can use that down here. Oh, okay, we already have one over here. So then we'll get the word to guess. Word to guess is keyboard.nextLine. Cool, and then we can return the word to guess. Again, you might also see people just say return next line. Nothing wrong with that. If you want to save it to a variable first, go for it. It doesn't really make any difference for us here. The one nice thing about this is if you run it in a debug mode, you can see the variable first. So for us, if we just grab it and return it, we're not really gaining anything. But if you're doing any sort of arithmetic, sometimes it's nice to have that step where you're saving it so you can see it happen before you return things. Just an option. And so we asked them for the word to guess. Great. Let's see. So we asked them for the word to guess. Asked them for the number in the range. Is still playing. Okay, we need is still playing. Display the blank. Okay, we're getting there. Display all the previously guessed letters. And now again, we can pass them the letters guessed, right? We don't necessarily need those to be static values. So if we have display all the previously guessed letters, we can give it the letters guessed, or we can make a static string for it. Again, it's sort of bad form to have public static things. We'll talk more about that when we talk more about classes today. Like this idea we want to encapsulate all of our details. You don't want lots of static variables usually. So if we can pass it, it's probably better. So to display all the previously guessed letters, we can just print you've already guessed or you have guessed plus the letters guessed. Right? We have them all here. They just keep on sticking letter after letter after letter after letter here. Right? Ask the user to guess a letter, given a string, making sure they don't guess the same letter twice. So we're going to need those letters guessed if we are going to make sure they don't guess the same letter twice. Right? So we can go fix that one up here. We'll have to pass the letters guessed. So ask them to guess a letter. Okay? So sure. Guess a letter. Oops. And then we can get their input. So we can get the letter as keyboard.nextLine. And then we want to check if that letter has already been guessed or not. Okay, so we need some sort of loop that's going to keep them in it and keep asking them over and over and over if that letter is in it already or not. So we got a couple ways of doing that, right? This sort of, let's loop through and if we've seen it, yes or no. Probably pretty straightforward. If you haven't seen the contains method, if you've seen the contains, you can say letters guessed dot contains. So if you look something up online, like how do you find if a letter's in a string, they probably told you you can use contains. So some string dot contains will tell you yes or no, it contains it or not. So if you didn't do any looking up, we could do another loop though, right? I'm open to either. Do you want to do contains or do you want to do the loop? Nobody has strong opinions?
Do the loop.
Sure, we can do the loop. All right. So we need to loop through then. And we need to make sure also that you probably only guessed one letter. We could check that too. Got a couple things to check. So we can make sure that we get just a single letter back out. We can say while letter.length is greater than 1. Keep on doing this, right? So this was just kind of a bonus sanity check. And I think I said it's fine. You can assume they'll do the right thing. But this is pretty quick. So only a single letter. And keep on asking. And just to make sure we get just one letter out. Okay? Then we can go and check and see if that letter is already in. So we want to do, we'll have a Boolean for already guessed letter. We're going to set that as false, because we don't know if we've already guessed it or not until we see it in the list. And then we can loop through for char letter, I don't know, guessed letter again. Guessed letter in the letters guessed to char array. And then we could just, now the string letter here is probably just 1, but we don't know how to get just that first character out. It's nothing we did, so we can do another loop too. And say for char current guess in the letter to char array. And if the current guess is equal to the guessed letter, if we find a match, right, then we know that we need to have them guess again. This was no good. Right, so I already guessed the letter and become true. Right? And really, I guess we can just do a silly do loop if we wanted. We could do, right, because we're doing this once, while they already guessed the letter is true. Now it doesn't like that, right, because we defined it here, so we got to define it up above. Let's do, that's why I hate this one. That's all right. Just make sure we're resetting it to false each time in the loop. Right, so we're going to start it off as false. I guess we started at false here too, it's redundant. We'll have them guess a letter, make sure it's just one character, right? If it's more than one, stick them in here. This was bonus, just for fun to validate. And then we're going to look. Hey, if we already guessed the letter, I'm going to assume no until I know otherwise. So for every letter that I've already guessed, let's loop through and find. Now, I know this is only one character, but we don't really have a way of checking is it one character or not at a time. Right? We can go see, okay, if I found it, if they match, then yes, it's true. And I'm doing this as long as that's true. If it never gets set to true, then it stays as the default false. I haven't guessed it already. I'm done. And then we can return that letter. Oh, goodness. We need that string out here, too. String for letter. Probably just empty to start. Sure. There we go. So we'll do all that, right? As long as you need to. Keep on asking until they give me a letter that's not been guessed. Okay, I think we got almost everything in here. We don't have is still playing. We'll get to that in a minute. I think we can probably, oh no, we need that because that has to give me back a value. But I wanted to try and run it and see how close it's going. So we're just going to change this to return a true for a second. And I want to see if we can start guessing and start getting some of these things displaying here. Right, I want to write a little bit and run some, write a little bit and run some, see how it's working for us. Over here, output, maybe. All right, what word should we try and guess? You want to guess Eric? Oh, I can't even spell my own name. That's embarrassing. How many guesses do they get? 30. Oh no, how many guesses do they get? 0. How many guesses do they? Okay, that's working all right so far. Oh, 5. Uh-oh. I got all my blanks on one line. All right, well, we got to fix that. So instead of the print line, right, we should probably just print. And then when we're done with every character, then we can just print a new line to go down to the next line. Right? We don't want every character, every underscore on its own line. All right, so, well, we can keep going. We can try it. So guess a letter. Let's guess something long. Only a single letter. How about A? You've guessed A. Guess a letter. Here's all of our blanks again. So it was not in there. We got one wrong. B, C, D. Oh, I found my C. Right. E, R, lowercase r. Uh-oh, we got some casing issues here. We can fix that. I filled it all in. We're not done, right? That still playing loop is just going forever. But it seems like we're filling in okay. Right? We're adding one letter at a time. Oh, I didn't try a duplicate letter. We should try a duplicate letter. We'll do that one next. It seems like it's working okay so far, right? So how do we figure out if we're still playing? Oh, well, we probably should check our number of guesses too, right? Number of wrong guesses we haven't been doing here. And our number of allowed guesses. So our number of wrong guesses here, every time we get a guess wrong, right? So we have, well, how do we know if we got the guess wrong? Right? We're getting what the letter is, so we should check, right? If it's a wrong guess or not. So, sure. Do you want to do another loop, or do you want to use that contains? All right, sure. So we can say if. Oh, we just have the letter guessed. Oh goodness, we have to do that in guess a letter. So here we go. So in the guess a letter then, right? Oh, we also need the word to guess then, because we're not returning. Oh, we return. Okay, so we have to change this just a little bit. We want to return that single letter, and then we'll add it to letters guessed. So this will be the string for the guess. And then we'll take the letters guessed plus equals the guess. Because that way I can check this single guess right here, right? And we can do it as a method, right? You know, might as well add another method here. So check for incorrect guess, given the guess and the word to guess. How about that? So if I give you both those values, then we can go and write a method for it. Static void given a string guess and a string word to guess. Okay, so we need to see, is the guess in the word to guess? So okay, we're going to do the contains, right? So this one's nice and easy. We can say if the word to guess dot contains the guess. So if the guess string, and you can do this with any sort of strings, like any sequence of strings too. It doesn't have to be a single one. If you Google that, it just says, hey, is it in the other one? Does it match? So if it does, well, really nothing happens, right? Or do we tell them they guessed it right? Or just, I mean, they'll see it here. So really we kind of want the opposite. So if it's not that, then we can take our number of incorrect guesses, number of wrong guesses plus plus. They got to guess wrong. Right, we should probably start that off at 0, right? So we can add to it. So they have one wrong guess. Or, you know, maybe this, that should probably start when we play again here. Right, start that off at 0. That's better. So every time we play again, right, it resets to 0. Otherwise, our guess count is probably going to be a little off. Okay, cool. So our wrong guesses goes up by 1. That's all it is. And I guess we could tell them, right? Or it's, I don't even know if we need to tell them, because they're going to see that the letter shows up and no letter pops in. I don't know. Maybe not. Okay, so sure, check for the incorrect guess. Well, that was pretty quick. But sure, that could be its own method. And then we'll add to the letters guessed, and we're going to keep on going. So is still playing then probably needs some more information. Right? Is still playing. We have the number of wrong guesses, the number of allowed incorrect guesses, which is wrong and incorrect. I'm using the wrong two different terms here, which is probably incorrect, probably wrong. That was on purpose. All right, it's too early to be silly. It's not even funny. All right, so well, if we're still playing, so we can check, right? If the number of wrong guesses is greater or equal to the number of allowed incorrect guesses, you can return false. Right? That's pretty straightforward. If you have too many wrong guesses, game over. Right? And we could even tell them maybe that they ran out of guesses. You ran out of guesses. Sure. We can do that. Now the other case though is that if they have solved it. So to check for that, we need the word to guess and the letters they've been guessing. So when we check if we're still playing, we need the word to guess and we need the letters guessed. Letters guessed. All right. So we can go add some more arguments down here to our method. This will be the string word to guess, and a string for the letters guessed. Guessed. Goodness. Okay. So first case, that's a quick, easy check, whether or not we ran out of guesses. The next one is, have we guessed everyone? Now, for this one, you kind of have to think about which default case is the easier one to work with. So I think the easier default case to work with is we're going to say, okay, yes, you've gotten it right, unless we find a letter in the word to guess that hasn't been guessed. Right? Because to try and track, is every letter that's been guessed has been guessed? Well, I would have to loop through my word that I'm guessing, and then loop through the next one, and if I don't find it, then I have to mark down a false. But if I do find it, well, nothing changes, right? If we can't say, okay, if I find the letter, mark it yes, and then go to the next one, mark it yes, find the next one, mark it yes, find the next one. Well, if I don't have the one, I mark it no. Right? We run into some trouble here. So I think the easier way then is we start a little Boolean and we say, right, is every letter guessed or something, right? Is every letter guessed? We're going to say true until we know otherwise. So we're going to loop through for character letter in the word to guess. Word to guess. That toChar array. And then for every letter here, we want to loop through every letter that we have guessed. Again, so for the character, the guessed letter in the letters guessed. toChar array. Now, if I don't find a match, now most of them aren't going to match, right? But I need to find, eventually there needs to be some match, right? So I guess even really right here, we can set this, we'll have here has match, or has been guessed. We'll set this one to false. And if I do find it, then, right, if my letter matches the guessed letter, then we can set has been guessed, has been guessed. I can't spell, friends. I can't spell. Set that to true. At the end of that loop, if this is still false, game over. Right? As soon as I find one of my letters that has not been guessed, I'm done. Right? So inside this loop, then, actually we can skip this one here. This one's nice. We can say, if I got here, and if has been guessed equals false, or you could say if not has been guessed with the exclamation mark, either way is fine. If it's false, and I've checked every letter that's been guessed already, I'm going to return false. I can just bail out. As soon as I find a letter that has not been guessed, I'm done. If I get through this entire loop, and I've not bailed out, right, and I've gone through every letter in the word to guess, I can return true. So we don't even have to mess with that flag, setting it true or false. So we could set that other flag to false that we had up here. I was saying, like, has the entire every letter been guessed? We could set to false, and then you could just return that Boolean if you wanted, or you could just have two returns. Either way works. Right, so I'll leave that in, I guess. So I can have a Boolean. Every letter has been guessed. Guessed. We're going to assume it's true, right? Unless we set it to false. So in here, then, if it's false, we set it to false. And then instead, we could just return that value here. Does that make sense? So we could set it to false, and then we could return that value true or false, or we could just return false or return true. Either way works. Right? They're just options. So maybe I'll leave that commented out. It gets upset if you have two returns in a row because it knows one will never get reached. Okay. think that's it then. Should we see if it works? So a bunch of loops, right? And this idea of having that Boolean, that flag for has something happened or not. Right? Have we seen this thing or not? Let's try it. All right. Let's guess Eric. 5 guesses. Uh-oh. He did something wrong. Well, that stopped way too soon. So let's see. Is still playing. We definitely didn't run out of guesses. Right? But I don't think we did. Did this one tell us false? Has every letter been guessed? It's still... Oh, I'm backwards here. So this is if we're still playing. So if we haven't guessed the letter, we're still playing yes. I've got this flipped here. So if we are still playing, then that's a true. And if we have guessed everything, that's a false. Right? Because it's still playing is yes. So what we're returning here is whether or not we're incomplete. So if we're not incomplete, right, then we have finished everything. So we'd have to fix this around. Every letter has been guessed. Yeah, we'd have to return not every letter has been guessed if we were using our flag here. Or we could have the flag like still guessing or something. Let's try that again. Oh, we got to fix the casing too, right, for uppercase and lowercase. So we guess Eric, 5 guesses, right? A, B, C, D, E, F. Oh, we ran out of guesses. Okay, that seemed to work, right? Should we see if we can actually guess it right? Or do you want to fix, we can fix the casing here too. So when you ask them for a word to guess, remember you could do this to upper. We look at that. You can to uppercase a string. Does that ring any bells? Right, so if I just uppercase the string here that I'm guessing, I'll have that. And then we ask them for a guess here. Return letter to uppercase as well. Let's uppercase everything. All right, what word should we guess? Someone else give me an interesting word.
Boat.
Boat? And how many guesses do we get? 6 guesses. What letters? A B? Hey, we guessed a B.
You know.
No? We got no. B. Uh-oh. Bob. I shouldn't have done that. What did we do wrong? Good guess. All right, so that's when we ask the user for a letter. Ask the user to guess a letter. So if we've already guessed the letter, if the guessed letter, current guess equals the guessed letter, already guessed the letter is true. Should have done that for us. For our letters guessed. Oh, we didn't uppercase that one either. That one hasn't been uppercased. So when we guess the letter here, we need to uppercase it again to uppercase. Because the letters stored now in my word to guess are all uppercase. And we got to uppercase this one too. Oh my goodness. All the uppercase letters. Right? Anytime we're getting their input, we're going to uppercase it here. It's a good catch. Good catch. All right, so we go back and stop that. Let's try it again with boat. Boat. B. Oh, that's now it's not a number. Boat. 5 guesses. B, O, B, 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 O. 1. Uh-oh. I mean, that's your own fault if you're guessing numbers, I guess. T, Z, A. No, we got it right. Maybe we didn't tell them we got it right. That's a little bit ugly. Maybe we should print it out one more time. I don't know. There's a lot of ways to make it look pretty. Where should we do that? If we did guess it right, we just print it one more time. We can just do it one more time. Or just print, I guess we just print the word. I don't know, this will have the same format this way. Print it one more time. Because this way, if they got it wrong, if they got it wrong, we should tell them what it was too then, right? Do you tell them what the word is if they get hangman wrong? the word was, I don't know, we'll just put the word to guess. We'll just do that. That's fine. Now, either way, right or wrong, we're going to get it now. All right, what else should we guess? Any other words? Apple? All right. Oh, this is good. It has a double letter.
I was gonna say it with the double.
Yeah. All right, let's get 3 wrong guesses here then. We guessed the P. Hey, we got double letters. Worked out. E, F, B, T. Oh, we ran out of guesses. The word was apple. Okay. How you folks feeling? We get it done? It's a little funky with some of these loops, but this was practicing loops, right? All the loops, practicing loops. Okay. Like a do again loop, validation loops. These whether or not I have the flags, it's a helpful way of, you know, we view something, and if we find it, yes or no. Right? This is what we can track.
You said you don't like the while loops.
Yeah, I did one, but I don't like the while because you have to put a semicolon here. And that's just ridiculous to me. Because a regular while loop doesn't have a semicolon, but a do while loop has a semicolon. And I've done it long enough I remember, but
You would say you don't.
you could do the exact same thing. You just need to set it so that it runs at least once. So like while I already guessed the letter, I would just set to true and say while that. And then it would get set to false inside the loop here. Right? Yeah, generally I avoid them, but it's probably fine to show examples of do loops every now and then because they're not terrible. It's just you'd have to remember there's a semicolon here. And then if you do a while loop and you put a semicolon in, it's an infinite loop because it says, oh, this is your entire loop here. I will run forever if you do your semicolons. And I spent like half an hour debugging something one time. I couldn't understand why it wasn't going anywhere. That's all. Yep. Cool. How's Hangman? Is it like actually a playable game, sort of? Maybe? You can hit run, put in the name or a word, and let someone else guess it. Not the most interesting thing in the world, but yeah, so we've done random number generators, right? We used random before to get random numbers. We haven't talked about arrays or like a list, essentially. But you can have a bunch of words. So I've got like a list of 1,000 common words you could throw in here, and then it would pick one for you, and you could just guess it yourself. Honestly, that's not all that interesting, though. And then for debugging, it's a lot easier, like if you just pick your own word yourself, because you know what to expect. Cool. All right, should we take a break now or move on to classes? Keep on working on our classes. I can do either. All right, let me commit this to GitHub, and then we'll keep it moving then. I can get GitHub to load. Come on. There we go. 100. Here's project 2. Not much of a shell anymore. All right, commit and push. We'll come back to our classes project. All right. Okay. So we've done bank account, we've done rectangle, and then we've used them a little bit, right, to do some things here. So the idea with the class, right, is that we want to now change how we're dealing with our code so that our code represents an object, like something in the real world of a noun, person, place, or thing. It has all of its attributes, and those are all of its private instance attributes. So every bank account will have its own balance, its own owner, its own type, its own number, right? None of these things are shared, right? So if you have a bank account and I have a bank account, our attributes are separate in memory, which is good. Then we can interact with it, right, with these public methods, like, hey, I can deposit, or hey, I can withdraw money from the bank account. The sets and gets are kind of boring, but that's how you can set attributes or get attributes, unless you give them in a constructor. The constructors are special methods. Their job is to create the object and to give values to all of the attributes. Right? That's the constructor's job. So we should probably also set balance then to 0. It's happening automatically. So by default, any numeric values are 0. Right? Any reference types, any objects are null, and nulls crash things. Right? So nulls are bad. So we wanted to go and set owner to some sort of string here. So if you give me the owner, great, we're good to go. So if you write a constructor method, the only way you can make that object is by giving it those values. Right? I can't make a bank account with new account, new bank account with empty parentheses. It's going to yell at me. It says, constructor bank account in class bank account cannot be applied to the given types. Requires string int. Found no arguments. Right? I gave it nothing in the parentheses. It needs a string, and an int. Now, it doesn't know, right, that we can give it empty 0. Right? That's a string, that's an int. Unless we do something in the constructor to check for, hey, is it an empty string, and is the number valid? The bank account class could care less. Right? The class is just a way of holding the attributes and a way for us to interact with it. So you can put money in, you can take money out. I don't know why it's beeping, I'm sorry. Am I bumping something? So the class, right, just has the logic. So we did have some sanity checks for deposit and withdraw. Right? We're making sure, hey, you have to deposit a positive value. I don't know what I'm sorry. It's going to drive me crazy. And we have to withdraw not negative, and you can't withdraw more than your balance. Right? We're making sure both of those things are valid. So when we talk about object-oriented programming, we have this idea of abstraction. The only thing that you need to know about bank account is the public methods. So if we got a class from someone else, like the integer class or the scanner class or the things we've been using in the Java library, we don't know how they work. We just know you ask for a new one, and then you call its methods. Right? So that you get to work with objects in this abstract manner, which is awesome. We don't have to understand how all the stuff behind the scenes works to use objects. So that abstraction idea, right, we just get to work with those public methods that are exposed. And hand in hand, we have encapsulation. We're taking all of the details, putting them together into one nice little bucket, one nice little class here, hiding away all of these attributes. No one can go and change these aside from my method. So if I don't want you to change the balance, there is no set balance method. Right? You can't just go tell the bank how much your balance is. You have to go and deposit or withdraw money. Right? For rectangle, sure, you can set the length, you can set the width. We'll let you do that. But again, we had our own little sanity checking, making sure you had a positive value for length and width. You could set the color, sure. So some objects will have, you can set everything, some classes, some you can't. It just depends on what makes sense for that object, how it's going to work in our code. So we've taken all those details, we've encapsulated them in, and the only thing we give people is our abstract public methods to interact with us. So they work hand in hand. So these all now are using instance attributes. Every bank account will have its own set of these values. But you remember the way we did integer.parseInt, you don't have an instance of integer to call the parseInt method. We just say, hey, this class here, please do this thing. It's different than scanner. Or with scanner, you had to make a new scanner. Remember, new is the keyword to make a new instance of that class in memory. So the difference is this creates an instance in memory, so all of the instance attributes get initialized. Right? We're going to have another one of these in memory. With integer.parseInt, this is a static method. You don't need an instance of integer to do these things like parse int. You can write static methods. So you can make classes with static methods of your own. Again, not super interesting, but we can do some little math examples because those are usually fast. We'll call this fun math. Now the difference is with static classes and static methods, there are no instance attributes that you can reference, which I think makes sense, right? If when you want to parse an integer, you just give it the thing you want to parse. It doesn't need an existing number to look at. So the same thing with our math. So to write static methods, we bring back that static word. So it's public static. What do we want to do? Like difference, int first and int second. And we're going to return first minus second. Public static int, there we go. What type? So public static means you don't need to make a new instance of fun math. You can just say fun math dot do this thing, please. And I can return the first minus the second. So over my class then, if we wanted to use that, I can just say fun math dot, fun math dot, and I'm going to see there's a method now. A static method is defined once at the class level. So I don't need to say, hey, I have a new fun math, and that variable for my fun math I can do stuff with. It's just static. So just like integer.parseInt, it's defined and you can use it. So for static methods, are called with the class name. 0 minus 0 is not very interesting. We could do like 4 minus 2 or something. Sure. You do some math. So you can have any sort of public static methods, and that's what's in the math library, right? When you do math stuff in Java, these are all static methods here. Because you don't need an existing number to tell me what the absolute value of another number is. Right? You don't need an existing number to tell me what the floor to round down a number is. So it's just pre-built code. Here's a class of a bunch of methods that are they're still all related. So like math is not a great noun. I guess it's a thing. Probably fits technically for nouns. I don't know if any of you are better at English than I am. And all of these things are math related. So we just put them into one math class. And we give you a bunch of public methods. There might even be some helper methods. I don't actually know what's in the math class. I haven't looked in quite a while. What's actually in it? Well, we could see if we really cared. But all of these things happen without you having to create a new instance of math. That's the big difference. Where with a bank account, you have to make a new bank account. So the new keyword goes and tells Java, hey, I need all of these attributes to go be loaded up in memory. Now, the other funky thing you can do, and there's good reasons to do it. We're not going to bother, but just keep it in your back pocket. I think next class you might play a little bit more around with it here, is if you wanted to, you can mix and match. So we can have static values and instance values. So instead of you telling me what your bank number is here, what we can do is we can have a private static int next account number. We're going to start that off at 1. And instead of you giving me a number here, I'm going to take the static next account number, and I'm going to take my next account number plus plus. So if there's a static value, it's defined once at the class level, and all of the classes will share that one value. So every time I make a new bank account, it's going to increase that number by 1. So it's still private, so no one else has access to it. So I can't just say, hey, bank account dot, what's the next account number? But inside the bank account code, private, again, means only inside the class can you touch it. Right? Versus public means anyone else can get at it. So the next account number, right, I'm going to grab, so every time you make an account, I'll just number them for you, which is what banks do. Right? You don't tell the bank, hey, I want account number 1, 2, 3, 4. They say, oh, here's the next number in our pool. Right? They keep some sort of system here. Again, it's not actually in their code. I'm sure it's in a database somewhere. But for our purposes, we can do it here in our code. So now I don't need to give you a number, right? I just give you, hey, I want this and this. And then I can print out what that account number is. Your new account is number with the new account dot get account number, or get number, right? Get number. Sure. Plus here. There we go. And then we do the same for my checking account. That was this account. Okay, we're going to see this one should be number 1. This one should be number 2. Okay, first account is 1, second account is 2. We can even watch it in debug mode. Debug mode is really your friend when you start working in classes here. So I'm going to put a breakpoint here at the constructor. Right, I'm going to run it with debug mode. So it's going to stop here for me, and then I can step in and I can see all the values, because it's a lot of fun. And it's a little small up front, sorry. All right, so now we're ready to run. So I want to step into, I don't want to step over, I want to do the step into. And I'm going to move into the constructor now. And I can see, now this, right, is my current instance. This is the instance we're working on. So in this case, the this, I'm calling new account. So anything attached to new account is currently the this, because I'm working with new account. I gave it a blank owner and a blank type. Sure. Owner, nothing. Now I don't see the account number currently. If I pop open this and I open up the static section, I'll see new account number. So it's static. The static values are shared among all instances of the class. So I can see it inside of there if I want. And I'll see that goes up by 1. Right, my static value is now at 2. So if I were to change this for fun in debug mode and put this at like 100, remember you can change values in debug mode. That's kind of fun. We'll put that at 100. Got our balance. Great. That line is done. We come back to where we were. Here's the new account number. We'll make another account. And we print that one. Now in my output, where did my output go? That was this one, right? There we go. New account number was 100. Right? We changed it, so now it jumped. Because that value is shared. If any one of those instances of the class change it, it's changed for all of them. So you can mix and match static with instance values. Just know that you can do it. We're not going to do anything like that in our project. It's nothing we need to worry about. The other thing you might use it for, not necessarily something that's going to change, but a static final value. Right? If you have some sort of value that is the same for everything, you can make a static final value. That way, every class, every instance of the class that you load doesn't need to store that. So if we had some sort of trigger in here, like a maximum value doesn't make sense, but if you wanted to track, hey, what's the withdrawal or deposit limit in which we need to report something to the IRS? You don't want to store that number for all 100,000 accounts that you have on file, right? That'd be a waste of memory. So you can store it one time. If it's a static value, it's stored once for all of them and they share it. So then we can go change it from 10,000 down to 600. If that, did the law actually pass? I don't remember if it actually passed or not. Or was it even a law? Was it just a directive? I don't understand how politics work. Go take a poli-sci class. It's actually really interesting, like how the government works. Still nonsense, but still interesting nonsense. Does that make sense? How we can mix and match static? We could do all static if you wanted. Here's just a bunch of helper methods that do things, like a lot of the Java library. Or you can have static values that are shared, and they're different from the instance values. So you can also add static methods to here. I don't know why you'd want to do that, but we could, I guess. Public static. Let's say int get next number. So we can return the next account number. So you have access to static methods, or static values in static methods. But what you can't do is I can't say this dot. There is no this. Right? There is no current instance when I use get next number. So I don't have access to balance, owner, type, or number. Those ones don't exist here because they're non-static values. So if I wanted to say balance, I don't know, plus plus, it's going to say non-static variable balance cannot be referenced from a static context. It's a fancy error, but it's saying, hey, you're in a static method, you can't get at things that are not static. It's actually a useful error, right? So that doesn't work for static methods, but in a non-static method, you can get at static values. So it's only a one-way street, because the static values are shared. They're always accessible, whether or not we're in a instance method or not, right? A method that's working on a current instance or from here. We can't access non-static attributes from a static method. Okay? Is that making sense? All right. So that about wraps up classes. Again, you'll take a deeper dive in 2151 if you continue on in the programming track. I'll get more into classes. The next topic we're going to talk about is testing. But it's been almost an hour. I was going to go grab a Coke, and we'll come back talk about testing on how, yes, it's nice that we can run a main method and we can look at, okay, I know that I should get this account number, and then the account number should be this. I know if I deposit money, my balance should go to this. Right? It's all things we're kind of happening in our head and taking for granted that, okay, I'm going to run my program. I know what it should do. Does it look like it did what it was supposed to do? Right? That's what we've been doing. That's what we did with Hangman. I know what's supposed to happen. Did it happen? Sure, then that's all well and good. The problem is, like if you've ever read one of your own English papers and tried to proofread it for errors, you know what it's supposed to do and know what it's supposed to say, and sometimes you skip over it, you miss it, because people are bad at that sort of thing. You know who's really good at that sort of thing? Computers, right? You tell the computer, I expect this to happen, tell me if it did happen. It's going to do it every time. And it's going to be really good at it. And it's going to be fast, right? Faster than we are. Okay, so we're going to look at how we can make the computer do that testing for us. Now, the good news is the computer will do it. The bad news is we have to write code to tell the computer to do it. Or maybe that's not even bad news. I mean, hopefully you're here and you're enjoying writing code, and you find power in writing code. Like, it can do cool things, right? You can make the computer do anything we want it to do if we can write code. It's really powerful. But we have to write the code to do it. Okay? So we'll take a break. We'll come back. We'll talk about testing. We'll talk about the next project, which will have us write classes and test them using this method here. Okay? So we'll take a couple minutes. I'm going to grab a Coke. I think my sugar's getting low, too. I think we'll grab some sugar. Yep. And we'll go from there. Let me put some music on. Go to break. So this puts us at 10 minutes is 11:12 a.m. We go from there. All right, awesome. Alrighty. We're going to talk about testing. So the first thing to note, the type of testing we're going to look at doing today is unit testing, testing one unit at a time, a small bit at a time. When it comes to software testing, there's different levels of testing, and essentially they're like, what size of the system are you testing? So for unit testing, we're testing one small unit. Essentially, we're going to test one method at a time. It's about the smallest unit that you can test, right? So we're going to take our class, we're going to test, does this method work? Does this method work? Does this method work? Right? When you get larger and larger and larger testing, you can get into integration testing. Is like, does your code work with each other? You can get system testing, right? Testing the entire system at a time. You can get end-to-end testing. Testing, does it actually work if I deploy it or run it at a customer site? That sort of thing. And you'll talk more about testing in software engineering courses. But for our purposes, we want to talk about unit testing. And does the method that I wrote work? And generally, the idea here is that any code that's worth writing is worth testing, right? If you wrote some code, it's worth making sure that it did what it's supposed to do. And if it's not worth your time to test, I can turn the music off, I'm sorry. If it's not worth your time to test, it wasn't worth your time to write. And again, that's sort of a bit of an extreme that, yes, I'm going to test every bit of code I write, but when you get out in the workforce and you actually write code that someone pays you to write instead of paying the school to make me have you write code, eventually someone will pay you to write code, which is super cool. They probably want to make sure that they paid you to write good code and working code, functional code. So it's worth testing. But again, different organizations have different standards around testing, and maybe you'll test different ways and sorts of things, but it's a good habit to get into. So what we're going to do is we're going to let NetBeans do most of the work for us. Like usual, any good IDE is going to do most of the work for us. So I'm going to come over to bank account. I'm going to go to navigate. I'm going to say go to test. So right click in your class and go to test, and it's going to say, oh hey, do you want to make a new test class? Yeah, we want to do that thing. So there's a couple drop downs that are important here. The first one is this framework. Now the Java with Ant we've been doing doesn't play well with the newer version of JUnit. I don't know why, but the Ant is simpler than the Maven and Gradle options that would work with the latest and greatest version of JUnit. Essentially it's the same thing, so I don't even know why there's a whole new version. So we're going to make sure you pick JUnit 4. So 4 is the slightly older version, but it'll do all the things we need it. There's some cool bells and whistles in the latest version, but again, we're not at that level. We don't need the bells and whistles. So 4. And then in terms of generation, what we care about is these 3 boxes are checked. None of these other ones are. Okay? That'll make life easiest for us. And we say, okay. Now it's going to add something over to this test packages section that we hadn't had anything in here before. Now we get a new bank account test class that showed up here. So whatever class you're testing, you get the name of that test. And it's going to have a bunch of methods in here already. Now, actually, we're going to get rid of a lot of them, but that's okay. All of them, you'll notice, have this at test. This is an annotation here that tells NetBeans and Java, hey, this is a test method here, which is really cool. So when we write our own, we're going to make sure we include this at test. So right off the bat, there's nothing in here, and that's okay. We're going to start adding things in. So what we want to do is we want to start testing one little bit of code at a time. So generally, that's one method at a time. Now, if you want to test a set method to see if the value is actually set, you have to also call the get method, right? I can't set a value and say, oh, I'm sure it got set. I need to go get the value to see what it is, what its current value is. So sets and gets go in pairs. So I'm going to get rid of anything that's just a get. Like get next number, we don't need. Get balance, we're not going to use separately from the other things. Get owner, we're not going to use separately from things. Get type, we're not going to use separately. Get number, we're not going to use separately. But deposit and withdraw and set owner are things we can test, right? We can test all of those ones. And then I'm also going to have, I'm going to add one more here to make sure that the constructor works. So just to make sure the constructor works. So I'm going to have at test, public void test constructor. Constructor. Here. So I'm going to add one of my own because I want to test that constructor method. Now what we're going to do is we're going to follow this convention. It's just a way of organizing things. Not a right or wrong way. I'm sorry, we can close that door again if you want. It's not a right or wrong way, but this is a very common way in the industry of organizing your tests, again, just to make them readable. As long as we're testing, the testing part will work on the computer side, but this sort of format here is to make it readable for people. So the first thing we're going to do is we're going to arrange, and then we're going to act, and then we're going to assert. So arrange is setting up all the variables you need to test. Acting is calling the code we're testing. And asserting is, did we get what we expect? Okay, so to arrange then, we need to give a couple things, right? We needed a owner's name and we needed an account type. Okay, so we're going to have a string for owner. We'll say Eric. We're going to have a string for type. We'll say checking. String here, there we go. And then what do we expect to get back out, right? With a brand new account, our balance should be 0, right? So I'm going to have a double for expected balance will be 0. And then I think integer for the expected account number or expected number, it's going to be 1, right? Because we were going to assign each account one at a time here, right? And we're going to call the code we're testing. So we'll make a bank account. So bank account equals a new bank account. Bank account, given the owner, the type. Okay, those two things. So we're actually calling the code. This is the code we're testing. We're testing the constructor right now, so I'm going to call it here in the act section. Then I need to ask it, hey, what are your variables? What are your attributes now? Because I'm expecting to get owner, type, balance, and number back out. So I'm going to have a string for the actual owner is the account.getOwner. I'm going to have a string for the actual type is the account.getType. Account getType. Then I'll have a double for the actual balance is the account.getBalance. GetBalance. And a int for the actual number, account.getNumber. Can't spell account. Get number. Okay, so I've called the code, and then I'm getting all the values back out, right? To see, okay, bank account class, what do you think your values are? And then we're going to go assert that they match. So there's two different asserts we're going to use. They're both called assert equal. So we'll say assert equal, and there's actually a bunch of them here. So if you type assert, you get a whole lot of, hey, what are these things we want to test here, right? Most of them are equal, but you can do true, you can do same, null, not null, equals, array equals, those sorts of things. But for now, we're going to do equals. So we're going to assert equals that the owner is the actual owner. Now you give it what you expect on the left and what you actually got back on the right. And what I mean by actually got back is what did the class give you when you called get, or when you called a method? What did the class give you back? So say, okay, do those match? And we'll assert equals that the type match the actual type. And then we'll assert equals that the expected balance match the actual balance. Now this is the one that needs to be different. When you're dealing with doubles, remember how Java is a little bit bad at math, and every so often you'll get like a trailing 10 millionth of a decimal point? Do we look at that if you just like add up enough? Did I ever show you that? Okay, we can do that real quick. That's fun. So if we just do some stuff here, so take off that breakpoint, have a double for some value equals 1, and then let's say while, all right, let's do a for loop. For int, I don't know, numbers 0, number is less than, let's do like 1,000, number plus plus. Let's take my value plus equals 1.1. We're going to go up 1.1 each time, and let's print out the value. Here, let's do it 1,000 times. So add 1.1 1,000 times, you should get 1,101, right? So we started at 1, we added 1,000, or 1.1 1,000 times, it should be 1,100 we got added to it. See what we get here. Oh goodness. Can't type number plus plus. There we go. Give that a run. Just pull hard. It's got a magnet. So like somewhere in here, you start getting some weird decimal places. I don't know why. There's reasons for this, I'm sure. Like, it's not what you'd expect. So it's good for a while, right? But then all of a sudden we get one, and then it goes away. Then we get 0.99. So we didn't actually add 0.1, right? It added like 0.99999. So Java, a little bit bad at math, actually, which is kind of sad. So when you're dealing with doubles, and you go to test them, here in our test here, you want to give it a delta. It's how close is close enough. So I give it, okay, compare this number and this number, and as long as they're within, we'll say like 0.00001, like there's tenths, hundredths, thousandths, 10,000ths, as long as they're within like 100,000th of each other, we're going to say that's close enough. Right? So this is only with doubles. So when checking doubles, you have to give the delta. Delta, how close is close enough? Okay, because stuff can happen. Java can suck at math sometimes. Now, you'll see we got close enough, right? Within 100,000 times when we ran that, where's our output here? We actually got the number we wanted, right? Or we did it 1,000 times. We still ended up at the number we expected, 1,101. But there was like 0.84. I don't even know what that is. Here's tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millionths, 100 millionths, billionths. So like 84 trillionths. We really don't care at this point. Now, if you're launching rockets, you probably care, right? We're not launching rockets. 84 trillionths isn't going to hurt. Even with our bank account, 84 trillionths is probably not going to matter. Although, if you actually watch the Office Space movie, maybe then you could make some money, right, off of those trillionths or something. Just don't screw it up. Anyway, so you need to have that delta. How close is close enough? Then we can assert equals the expected number. Oh yeah, and the actual number. So again, we're just going through, did we get what we expected? I don't need to write a main method now to go and give it values and get the values and print the values and have me look with my eyes and say, okay, did it print out the value I expected? We can have the code, hey, did it give me what I expected? It's the exact same thing, right? Here's a bunch of values. If I give it those values, do I get what I expected back out? It's the same thing we did in the main method, but now we're making the computer do it. Now to make the computer actually run it, you right-click and you say test file. And you get this really cool test view, which is really fun. It'll just take a second here. Let's see, here's all of our tests. Test withdraw passed, test deposit passed, test constructor passed, test set owner passed. Well, wait a minute, I didn't write code for any of these other ones. The funny thing is, the default is pass. So if it doesn't fail, it passes. And if you want to see it fail, we can change it real quick and say, hey, instead of 1, right, let's say, hey, does 3 match what we actually get back for our number? And I'll run our test again. We're going to get a big fat fail here. Failed, expected 3, but was 1. It's real tiny there, sorry, but it says, hey, you told me to expect a 3. I got back a 1. Warning, 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 warning. Something went wrong here. And you can actually see in here, like, oh, hey, this is where it all happened, which is pretty cool. So let me put that back. Okay. So for setting the owner, again, we're going to do our arrange. Arrange. We're going to act. We're going to assert. Now this one's not super interesting. And let's see, did we actually in bank account? Yeah, so we never used the set owner method. Probably would have been better to use the set owner method here, but again, it doesn't really matter too much. So to arrange, we'll have a string for the expected owner. We'll say that is Eric. Now, we're not testing the constructor here. So I'm going to put the constructor in the arrange section because I need a bank account to test with. So I'm going to make a bank account, default account equals a new bank account. And for now, I don't actually care what the owner is. I don't care what the type is, and that's it. So I can just give it empty strings. Those don't matter to me. When I'm going to test my code now, what I'm acting on, what I'm testing here, I'm going to call account.setOwner. Set owner, I'm going to give it the expected owner. And then I'm going to get a string for the actual owner. owner is my account.getOwner. Okay, and then I can assert they match. So assert equals the expected owner and the actual owner. So if I call set and I give it a string for the owner, do I get it back out? Now you might think this is a little bit boring and tedious, and yeah, it is a little bit, but it's good to check to make sure that I didn't typo anything in my actual class for bank account. Sometimes when you write a method, you screw it up. Now it's not likely, so this one's kind of boring, but that's okay. Any code that's worth writing is worth us testing. And we can test our file. So I don't care what the type was, I don't care what the original owner was, so I'm just setting it up and I'm going to call the sets. And it passes. Life is good. Now deposit and withdraw are more interesting, right? Deposit and withdraw. Now when we talk about unit tests, there's a way that you actually can quantify a unit test. It's a metric that you can use when you discuss unit tests, and it's called code coverage. So the code coverage is saying how many lines of code actually run when the unit test runs. So if we look at our methods here, in deposit, if the amount is not greater than 0, this line of code never runs, right? So if the only test I give it for deposit is a negative value, I don't have 100% code coverage. Not every line of code is going to run when I test my method, deposit. So to get 100% code coverage, we need to make sure we're testing all the different cases, essentially every different if block, right? Does this block of code run when my test runs? So deposit's not so hard, but with withdraw, if I only test that withdraw works, I'm never testing the false case here, I don't have 100% code coverage. So I'm going to need 2 different tests. I'm going to need a test to make sure that yes, it does work and I can withdraw money, and a test that no, it doesn't work and my balance doesn't change to get 100% code coverage. So it's a great target, it's a great goal, and it's an ideal. If we can get 100% code coverage, fantastic. Now, in the real world, we'd love to say, yes, we always get 100% code coverage. The downside is your time costs money, right? So to spend the time to test your code is definitely worth it. I'm always going to say it's worth testing your code. The downside is every single if block, if like we're being very defensive and protective and saying, okay, you can't give me negative, okay, you can't give me more than your money, okay, you can't give me this, you can't do this, right? If we're doing a good job in our code and making sure it's not going to crash and we're checking all of our cases, we'll call those edge cases, right? Like all these different things that could happen, users could give me bad things. That takes a lot of time. And we're not getting a whole lot of benefit out of it, unfortunately, right? It's good to make sure that, yes, it does what we expect and you can't give me bad values. But there's some diminishing returns. When you write your initial set of tests, you're going to get a lot of return out of it. You're going to get a lot of value out of it because we're going to check and make sure that most of their stuff works. We'll cover most of it. Sorry, my sugar's going low. Should come back up in a minute. But after that, the value of your investment of testing this one specific edge case, this one specific edge case, this one little condition over here, the value goes down. So not every organization will say, okay, we want to get to 100% code coverage, because that does cost a bit of money in terms of time. So it's an ideal, and it's great. If we can get there, awesome. If we can't, we shouldn't feel too bad about ourselves as long as we've tested most of our code, okay? And then the other thing, though, even if we get to 100% code coverage, doesn't mean we won't have mistakes. It's possible to still screw it up. It's less likely because we've tested it, but just like writing an English paper, if you know what it's supposed to do and you just kind of have that in your head and you do the wrong thing, it's possible to do the wrong thing here and do the wrong thing in your test. Just less likely. All right, so let's go and test. Test our deposit. So we need our arrange, we need an act, and we need an assert. So how do we know if deposit actually worked? Right? What is going to change in our bank account if deposit worked? What should change if deposit does its thing? The balance. Okay, so we need a balance. So we'll have a double for an expected balance. So what do we want the balance to be when we're done with our test? What should it be? We can pick anything. Sure, $1,000. Okay, so we expect to have $1,000 when we're done with our test. To get there, we need to make a bank account. Bank account equals a new bank account. Again, the owner and the type don't matter for our test here. Doesn't matter. Okay? Now, the code that we're testing is deposit. So now we can deposit. That's what we're going to do in act, right? Act is where we're testing our code. So count dot deposit. Let's deposit our expected balance. And then we're going to get back out. We're going to check it. Double, what is the actual balance? What does the bank account think its balance is when we're done? Count dot get balance. Right? And then we can assert to the equal. Assert equals the expected balance, the actual balance, and then how close is close enough. So if you forget to do that, it's not going to yell at you yet, but as soon as you go to test it, it's going to yell at you. Right? So it doesn't look like it gives you any trouble here. And this is the little downside of this. When it runs, though, it's going to say, oh, use assert equals expected actual delta to compare floating point numbers. Right? Okay, sure. So include the delta, 0.0001. All right, let's run this again. Let's test it. All right, that one passed, but now, uh-oh, our test constructor failed. We expected a 1, we got a 2. Remember that account number was static, and there's no guaranteed order to which these test methods are going to run. So it looks like test deposit ran first, and then test constructor ran. So our expected number is a little bit off here. So we can change that. We can do the account.get next number, right? We don't even have the account yet, shoot. So our expected number, hang on, we'll fix that in a second. After we make an account, this is a little bit silly here because we're using that static value, which again is kind of funky here. But we'll get the expected number. So we'll make an account. I don't even know. Is that even going to work? This is not great. You know, let's just skip that check here for the actual account number because it's not going to work. Okay, let me put that back and I'll just comment it out here. Expected number here, actual number, and the assert equals. And a little note, this worked well because we have no order guarantee with tests. Right? I don't know which test is going to run first, so we're just skipping it for now. Just leaving a little note. That's fine. We don't generally mix and match the static values. Again, the static value doesn't even really make sense because we're probably going to get that value from a database, not from our code. Right? And every time you run it, it restarts at 1. Right? Can you imagine your bank servers, they're wherever they're running their code, probably like turn off and turn on at night occasionally for patching or something. Right? It's really, really, really unlikely that they have their code that's running all the bank account management software and it never turns off ever. It's likely it doesn't turn off very often, right? Because that's a big process and you probably want the systems online, but to say never is probably pretty unlikely. Okay. So we'll just ignore that for now. That was just an example of how we can mix and match. And we'll go back and make sure our test runs. Cool, so it passes. Now, I do probably also want to test, though, that a negative number doesn't change my balance, right? That, you know, in terms of code coverage, we have 100% code coverage right now because it's all running. But we probably also want to test if I give it a negative value that my balance doesn't change. Because that was something that we explicitly said, hey, I'm only going to deposit if you give me a positive value. So I don't feel good, I don't have confidence that it's going to work unless I test it. So we'll say deposit. So you can't have two methods of the same name. So I'm going to say test deposit negative here. So my balance should still be 0 then, right? If I try and deposit a negative $100 or negative $1,000 or something, right? My actual and expected should be 0 if I try and give it negative money, right? You can't deposit negative. So just making sure that we wrote that condition to make sure we can't do this thing. Let's go and test it. Now, does it give me more code coverage? Like when I test my withdraw, it will. So that passed. All right, so testing withdraw, we definitely have two different cases. Negative or more than our balance gives me back false, nothing changes, or I can actually withdraw. So let's test the withdraw. So for withdraw, you need to actually put money in first, right? So for a range, what do we want to expect to have expected balance. So should we put 1,000 in and take some out? What should our balance be after we put some money in and take some out? What do we want to land at? 500, sure.
One payment down 500.
All right, yeah, we can do that. So we'll make a bank account. Bank account equals a new bank account. We don't care about the owner. We don't care about the type. And then I needed to deposit some money to start. So I'm going to go deposit some money first. Sure, we can just do that in our range. Account.deposit. Deposit 1,000. Okay, then we can actually act. And then we can assert. So we're not exactly testing the smallest bit of code at this point here because we can't test withdrawal without deposit working. So in terms of it being like a very pure unit test, someone who wants to argue is going to say it's not the purest unit test, and sure, that's fine. Because we can't make withdrawal work until deposit works. Right? So it depends on this happening, but sure, that's fine. There's no way around that. We don't care too much. So let's take some money out. So count.withdraw, and then I actually want to have, right, withdraw returns a Boolean value, success or fail. So I'm going to have a Boolean for my result here. Will be the account.withdraw, and let's withdraw 500. And then we can actually get the actual value out. So an actual balance is the account.getBalance. And then I can assert two things. So now with result, I can assert true the result. Right? You can assert true, you can assert false. Instead of saying assert equals true, just say, yes, it should be true. Right? Save yourself a little typing here. And then we can assert equals the expected balance, the actual balance, and the delta. Right? As long as we're within something here, we should be good. Let's run that one. So if I put 1,000 in, I should be able to take 500 out and have 500 left. Okay, that one passes. Good so far. Now let's try and make sure if I can't take out too much money. So if we put 1,000 in, I can't take out 1,500. So my balance should stay at 1,000, right? We shouldn't change the balance, right? Some people might say, oh, give them as much as they can get out. I don't know. We said just ignore the transaction, right? That's probably more fair. But now my result here should be false because we said, hey, give them back a false, but don't change the balance. So this is test withdraw, I don't know, too much. More than you have. I don't know. Come up with some nice name for it. Doesn't matter too much. And then we test this one. And that one passes. All right, life is good. All right, we've got the last assignment now. Oh my goodness. It is 11:40 already. That's what happens when you start 10 minutes late. I'm sorry. Close that one. There we go. All right, so for our next assignment here then, project 3, let's fire this one up. We're going to build a class, and we're going to write tests for it to get 100% code coverage. Let's do project 3. So 2 weeks from today puts us at the 25th. 10 a.m. I think that's right. I got to look at make sure we're not running into the midterm. That's a project for project 3. I think this one will be worth about 15 points here. And you can don't give me a file, just give me the link to the URL here. So submit URL feedback pull request along with a self-assessment using the rubric. All right, and then you need that GitHub Classroom link for the assignment. Where'd we go? Here we go. For project 3, that's the link. Okay. So we're going to write a class for we're going to write a vehicle class. vehicle class. Vehicle class, right? It'll have attributes for gas tank capacity in liters. Again, gallons are stupid. Our metric system or our imperial system's awful, so we're going to use the metric system. So when you give an attribute that is based on some sort of measure, you should tell them what the measure is. If you just say gas tank capacity, most of you will probably assume gallons. And I'm going to assume liters, and I'm going to try and put too many liters in the tank, and I'm going to spill gas all over the place, right? So gas tank capacity in liters, gas currently in tank in liters, like how much gas is actually in the tank in liters, a kilometers per liter average, and this is just like the EPA estimate. Just because they say you can get 25 miles per gallon doesn't mean you always get 25 miles per gallon, right? We know this is how that works in real life. For our purposes, we're going to assume we always get the average because it's hard to do an actual, right? So this is just our average here. We're going to have an attribute for make, model, and color, right? So you can have the make and model of the car, you can have the color of the car, and then we're going to have methods. So get methods for everything. We're going to include a set color method because you can change the color of your car, but you can't change the make and model, right? That once you have a make and model of the car, it doesn't change, right? Just like our account type didn't change, our account number didn't change, but you could change the account owner, right? You can change the color of your car. Then we're going to have methods for add gas, given a number of liters to add, and a method for drive, given a number of kilometers to drive. Okay. Oh, we already have that. So add gas. So it's given has a parameter, has an argument for that thing, right? So add gas and drive take arguments or parameters. Add gas. I think of, I'll just come down a line here. So add gas to ensure you don't put more gas in the tank than the capacity. Remember this idea of a class ensures its integrity. Right? We don't put ourselves in a bad state. Rectangle wouldn't take a negative value here. When we add gas, we need to make sure the actual gas in tank doesn't go above the capacity. Right? You can't put more gas in than the tank allows. Now, in real life, it would just spill. Right? In our code, we're going to pretend, right, whatever. It doesn't spill, we just stop here. So if I try and add 1,000 liters of gas and it only fits 10, stop at 10. Right? Make sure we don't go above the capacity. And we're going to return a true or false result. If you were able to successfully add that much gas. Right? True or false? True, I was able to add the entire amount you requested. If you said 1,000, I only could fit in 100, return false. But we're still stopping at that 100 mark. Okay? That's for add gas. For drive, we're going to have to calculate, right, how many liters it took. If you know how many liters per kilometers per liter you can get, if you want to go drive 100 kilometers and you can get 10 kilometers per liter of gas, it's going to take you 10 liters of gas. Right? We have to do that arithmetic to find out how many liters of gas, and then take the liters of gas out of our tank. Right? So we reduce the liters in the tank by the amount needed to drive the requested kilometers. But don't go below 0 liters in the tank. Right? If you want to drive 10,000 kilometers, but you can only get 1,000, we'll let you drive all 1,000, and then you have no gas left in the tank. Right? So the tank can get emptied here, but we can't go below 0. And we're going to return a true or false. False if they were able to drive the distance. to drive the distance. Okay? So let's drive, add gas, or how we're interacting with our car here, including our get methods for everything, set methods here, and then we're going to include unit tests to ensure 100% code coverage. That idea that every if-else block is tested. Right? So not just one test, hey, did we drive and did it work? We're also testing, hey, did we try and drive way too far? And did we get back a false result? And did we go to 0 liters in the tank? Right? Like we do with bank account. Did withdraw and deposit work? Feeling okay? All right, we got 2 weeks to work on this. Let me put a rubric in here. Oh, we need a constructor too. That's right. So we include a constructor. Include a constructor that accepts make, model, color, max, what is that, max, or gas tank capacity. Tank capacity in liters and average liters or kilometers per liter. Right. Oh, kilometers per liter average. Sure. So you have to take those values in the constructor. So the kilometers per liter is not going to change. I know it doesn't exactly work like that in real life, but we have no set method for this. So you're going to give it in the constructor and it's going to stay. Right? That idea, just like the account type, you're going to give it in the constructor and you can't change it again. So that value is going to be fixed once you make it, but it can be different for each vehicle. Right? If you drive a big old Cadillac, you're not going to get as many miles per or liters, kilometers per liter as you are in a small little Prius or something, right? Okay. So let me put the rubric in here for you real quick. Where'd it go? All right, at least let me save it and I'll come back to it in a second. Make sure that saves. We had, how many points was this one? I think this one was 10 points, right? For project 2? 11? Okay, so we're going up to 15. Cool. Yep, so it'll be worth a little bit more than project 2. So if you missed a couple things there, you know, we've got a couple more points coming for project 3. It's weighted a little more heavy. All right, cool. So it's project 3. Delete these ones here. So it's missing, no points, and if it's complete, there's points. So we have the vehicle class, all private attributes, and then the vehicle class has get methods, all the attributes, 2 more points. Vehicle class has set color method. That one only, let's do custom points here. Like 1 point for that one. Vehicle class. Add gas method. 2 points for add gas. 2 points for drive. Vehicle class or vehicle test methods. So for the test, I don't want to spell them all out here. So we'll just do the 6 points for the test methods, 100% code coverage. Right, so you're testing the constructor, you're testing add gas, you're testing drive, and all the different cases here should get you up to that. So like at least 2 for add gas, at least 2 for drive, testing that constructor here. Coverage here should put us about 6 points. That puts us at 15 total overall. How's that sound? But I'm not listing them all out. You're testing add gas, you're testing drive, you're testing all the gets with that constructor. You make it, all the gets work, that sort of thing. So drive won't work until add gas works, right? Because you shouldn't be able to drive with no gas, right? So they kind of depend on each other, just like you couldn't withdraw until you could deposit, that sort of thing. All right, that's not as many submissions as I thought we'd get for Hangman. That's a little unfortunate, but we'll go from there. All right, questions, thoughts, concerns? Got a little bit of time to hang out. If you want to work after, I'll stop the stream here. Ping me on Discord, call me, text me, email me if you've got questions. We'll go from there.